Have you ever wondered just how fast humans could possibly move? Maybe as fast as the world's fastest runner. Or maybe someday, with advanced spaceships, we'll travel even faster than we've ever imagined. But no matter how advanced our technology becomes, there's one speed scientists say we'll never beat. The speed of light? It's so incredibly fast that it almost feels impossible. But why is that? Why can't anything outrun light? And what would actually happen if humans could one day travel almost as fast as light? To answer that question, let's first understand just how fast light really is. Take the distance between Earth and the Moon, about 384,400 kilometers, or nearly 239,000 miles. If you drove a car the entire way without stopping, the trip would take around 160 days. Even using humanity's most powerful rockets, you'd still need about 3 days to get there. But light reaches the moon in only 1.3 seconds. That means a round trip takes just about 2.5 seconds. And that's only the moon. The sun is almost 390 times farther away, sitting roughly 150 million kilometers from Earth. Yet sunlight still reaches us in only 8 minutes. So, how can light possibly move that fast? The answer lies in what light is made of. Light is made up of tiny particles called photons. Unlike everything we experience in everyday life, photons have no rest mass. Because they have no mass, they naturally travel at the speed of light whenever they're moving through a vacuum. Humans, cars, rockets, even planets all have mass, and that's where the problem begins. According to Albert Einstein's special theory of relativity, published in 1905, the faster an object with mass moves, the more energy it takes to keep accelerating it. As your speed gets closer and closer to the speed of light, the amount of energy required rises dramatically. And the moment you try to actually reach the speed of light, the required energy becomes infinite. In other words, based on everything we currently know about physics, an object with mass simply cannot reach the speed of light. But what if, one day, humanity invents technology capable of traveling almost that fast? This is where Einstein's theory gets even stranger. Imagine boarding a spaceship headed toward Proxima Centauri, the closest known star to our solar system, about 4.24 light-years away. 2 people back on Earth, the journey would take over 4 years. But for you, time itself would slow down. This phenomenon is called time dilation. One of the most famous predictions of Einstein's special relativity, and it's been confirmed by numerous scientific experiments. But time isn't the only thing that changes. From Earth's perspective, your spaceship would also appear shorter in the direction it's moving. Physicists call this length contraction. Meanwhile, your energy would continue increasing enormously as your speed approached the speed of light, making it harder and harder to accelerate any further. It almost sounds like science fiction. Yet every one of these effects comes directly from equations developed by Albert Einstein more than a century ago. Then there's another fascinating question. If nothing can travel faster than light, why do we sometimes hear that something has actually beaten it? The secret is hidden in where the race takes place. The famous speed of light, about 299,792 kilometers per second, only applies when light travels through a vacuum. Like the empty space between planets, when light passes through materials like water, glass, or diamond, it slows down because it constantly interacts with atoms inside those materials. And that's where something incredible happens. Certain charged particles can actually move faster than light traveling through water while still remaining slower than light traveling through a vacuum. When that happens, they produce a beautiful blue glow known as Cherenkov radiation. Scientists often observe this phenomenon inside nuclear reactors. So, does that mean something has finally outrun light? Not really, because the ultimate speed limit of the universe is still the speed of light in a vacuum. To this day, no experiment has ever demonstrated that any object with mass can exceed that limit. Even so, scientists continue searching, experimenting, and asking new questions. Not because they expect physics to suddenly be wrong, but because every new discovery helps us understand our universe just a little bit better. After all, curiosity has always been the driving force behind science. The speed of light isn't just an incredibly large number. It's one of the most fundamental limits of our universe. Based on everything modern physics has discovered so far, thanks to Albert Einstein's groundbreaking work and more than a century of experiments testing his ideas, we've learned that reality is often far stranger than our intuition suggests. Maybe one day humanity will build spacecraft capable of traveling incredibly close to the speed of light. But for now, that cosmic speed limit remains undefeated. So if humans could someday travel at nearly the speed of light, where would you go first?